So this first section, we're going to be looking at rate of change and slope. So our first problem here says that the table shows the distance a man marches over time. Is the rate of change in distance with respect to time constant, and what does the rate of change represent? So we're first going to just count the distance from our x's. So these ones go up by 1, so the time goes up by 1, and then we're going to count the change here. So if you look here, to go from 260 to 520, you add 260. To go from 520 to 780, you add 260, and then another 260 to get to 1040. So our rate of change is 260 feet per minute for every 1 minute. So again, we just kind of put our y, the change in our y, over the change in x. And so that means that the rate of change represents that for every minute, the band marches 260 feet. So go ahead and write that down on your paper, that for every minute, the band marches 260 feet. Now in math, we call rate of change slope. So we're going to try to find the slope of the line. So when you find the slope of the line on the graph, we're first just going to start by counting. So when we count the rise over the run. So rise is up and down on the y-axis, and x is left and right. So we're going to count up. So we have 2 points here. We're going to go from each point. So we're going to start at this point here, -2, -1. We go up 2. So that's our rise, is up 2. And then over 3. So then our slope is 2 over 3. And it's going to be positive because if you look left to right on the graph is going upward. So it's going to be positive. This next example, same thing. We're going to count to the points. So we're going to count rise over run. So our vertical distance over the horizontal distance. So we're going to go up 4, and then we're going to go right 5, or left 5, sorry. So we have 4 over 5. And now if you look left to right, again, you always have to look left to right. The line is going down left to right, so that's going to make it a negative slope. Now here we don't have a graph, so we have to use the slope formula. So the slope formula is y2 minus y1 over x2 minus x1. So we're first going to label our points. Remember, the points go x and y. So the first one will be x1, y1, x2, y2. And then we are simply just plugging in. So if we look at our first number, y2, matches here with -2. So we're going to plug in -2 minus, and then y1 is 0. So we're going to plug in 0. Then all of that is divided by x2. So x2 is positive 3. And x1 is -1. So we have minus and negative there. And then we just have to simplify. So -2 minus 0 is -2. And then 3 minus a -1 changes to plus, so 3 plus 1 is 4. And then if we reduce this down, if we can divide the top and the bottom by 2, it becomes -1/2 would be our slope. So we're going to look at horizontal line, but we're going to start it off with the equation. So for the equation again, we have y2 minus y1 over x2 minus x1. So we're going to use these 2 points. It does not matter which one you make which. So we have x1, y1, x2, y2. So we plug in, y2 is 2 minus 2, y1 is 2, and then x2 is 2 minus -3, which is x1. And again, we're going to simplify. So you get 0 over 2 plus 3 is 5. 0 divided by 5 is just 0. So any line that is horizontal will always have a 0 slope. Always have a 0 slope. Now we have a vertical line, so we're going to look at what the slope looks like here. So we have y2 minus y1 over x2 minus x1. Again, label your points, x1, y1, x2, y2, and then plug in. So y2 is -2, minus y1 is 1, and then x2 is -2 minus a -2. -2 minus 1 is -3, and -2 plus 2 is 0. Now, you cannot divide by 0. You can never divide by 0, so this slope is undefined. So anytime you have a horizontal line, the slope is 0. So you don't have to do the work for it. Any horizontal line will be a slope of 0. Any vertical line will be an undefined slope.